On our previous generation Starlight mice, there were design deficiencies in both hardware and firmware that would adversely affect scroll wheel performance. This would intermittently cause users unintended ghost scrolls and reverse scrolls. For the UltralightX, we set out not only to improve the scroll wheel experience, but to set the absolute benchmark for scroll wheel performance and reliability, ensuring you never have a single unintended scroll during the life of your UltralightX. A scroll wheel encoder is called an encoder because it translates the rotary motion of the scroll wheel into two digital signals. These are coming from two sensor pins in the encoder, which are making contact with a spinning disc rotating when scrolling the mouse wheel. The disc will intermittently make or break contact with these sensor pins in a well-defined pattern. Finally, by looking at the digital pattern of these two outputs, we can determine the scroll direction and the amount of steps. Now, when dust finds its way into a scroll wheel encoder, it can interfere with the proper functioning of those crucial sensor pins and the spinning disc. These tiny particles can lodge themselves between the contacts and the disc, disrupting their ability to make and break contact accurately. As the encoder relies on the precise sequence of these contacts to determine the scroll direction and the steps, any interference from dust can lead to erratic or unresponsive scrolling behavior. Additionally, dust can build up and wear down the internals of the encoder over time. By sealing the top of the encoder used in ULX to fend off any dust particles, we ensure the proper functioning of the finely tuned pattern between the pins and the disc over the lifetime of your mouse, making your scroll experience reliable and predictable. We did not stop at just physical protection. We've added redundancy measures in the firmware to help ensure the signal integrity and quality, even in case the encoder is wearing out over time. The first measure is debouncing. As with any mechanical contact, it's important to filter out any fast-paced electrical on and off noise that is caused by the mechanical contact physically bouncing on the surface after making a transition. Debouncing is filtering out this transient noise, so the state transitions are much cleaner. Additionally, we implemented a digital filter that will apply a different algorithm depending on the high or low state of the encoder signal. This is done to match the physical construction of the encoder. It also includes reverse scroll detection and blocking to take into account the effects caused by a mechanically worn down encoder. Since performance is our first concern, we made sure all of this is handled as fast as possible. By using the hardware capabilities of the NRF52 MCU to the maximum extent, such as using direct peripheral interconnects and interrupts, we ensure minimum latency. All these engineering optimizations have been made to the ULX scroll wheel, so that no matter how hard you are gaming, whether you're in a tournament or simply playing ranked games at home, you will never have a moment of doubt when it comes to the reliability and performance of your mouse wheel.